So here's our problem. Global warming and climate change. In the atmosphere, the greenhouse effect naturally occurs. It traps some solar radiation from escaping back into space, and that helps to heat the planet. Without this effect, the Earth would plummet below negative 18 degrees Celsius, and we would all die, or never have existed for that matter. But thanks to an excess of gases in the atmosphere, such as carbon dioxide, more heat gets trapped in the atmosphere than necessary. So the world has begun to heat up. Burning of fossil fuels is to blame. All these excess gases are the result of burning fossil fuels. Using oil, gas, and coal releases these dangerous gases. 28 billion tons of carbon dioxide alone is dispelled into the atmosphere annually. Fossil fuels are mainly burned for electricity production. The main source of these emissions is from coal-fired power plants that produce energy that we all use every day. Every lighter computer that we see on is most likely powered by some sort of fossil fuel. So, what keeps our existence going is killing our planet. We use electricity to keep the world and our own lives running, yet what keeps the world moving, or its inhabitants for that matter, is slowly destroying it. Fossil fuels are very primitive. The burning of fossil fuels for power has been around since the Industrial Revolution. There may have been minor updates, but with such a massive demand, it just isn't feasible to use anymore. So we are in dire need of a solution. So there are a number of alternatives that could be utilized to support our world's power grid. For instance, wind power, a clean renewable energy with no negative impacts on the world. There will always be wind, so this power can always be used. Hydroelectric. Again, there will always be running rivers, hopefully, so this power will never deplete. Solar power. There seems to be enough energy from the sun to heat the whole Earth, plus cause global warming, so why not switch over to that? Or of course, there's thousands of others that could be utilized. But why do we want to utilize those if we can utilize nuclear power? An already developed technology that's been around for a good 50 years, it still hardly has been taken advantage of. A couple of the drawbacks of these other ones in comparison to nuclear power, such as wind power, to equal one 1,000 watt plus megawatt reactor would take 16,000 wind turbines, and at this point the biggest wind farm has only 200. For hydroelectric, it is very expensive, clogs up rivers, and adversely affects habitats of rivers. And solar power and the others, they may all be fantastic given time, but don't have the massive potential that nuclear power has displayed. Here we have a basic nuclear reactor. You have the core here where the U-235 fuel is fissioned to create the energy, heat energy. See, water flows in from over here and goes through the core. That water heats up and is pumped into here where it creates steam, and that steam is put into the turbine where the turbine spins a generator that ends up generating power, and that's how electricity is actually produced from a nuclear reactor. Now, on to actual nuclear power. So, we've gone through a basic description of how a reactor actually works, and how the fission process goes, that it actually works by a chain reaction, where after the initial atom is split, then those atoms diverge off, and they continue to split more atoms, which continue to split more atoms, and that continues the chain reaction, which produces the heat, which does the rest of the process, like was explained. Now for efficiency, as here. Nuclear power is a highly efficient energy producer. The energy produced by 2,325,000 tons of coal can be matched by a mere 150 tons of nuclear fuel, U-235. Replacement of fuel rods is only necessary every 1 to 2 years as well. So it's quite a bit better than the constant feed of coal that needs to go into coal-fired power plants. And the lack of emissions, nuclear power emits no pollutants into the atmosphere. Only steam is released from the heating of water inside the reactor, compared to a constant stream of CO2. Renewability. Used nuclear fuel can be re-enriched at a separate facility, making it available for repeated use. There are also fast breeder reactors, which actually create fuel during the fission process, which is then used by the reactor, which continues to make new fuel for itself. And of course, as with most things, there are dangers. And in the background here you can see the resulting danger of a nuclear meltdown at the Chernobyl power station in the Ukraine. First off, disasters. It is true that a number of unfortunate events have happened in the history of nuclear power, but in reality these are very few. The only two of any significance have been 3 Mile Island in 1979 and Chernobyl in 1986. The recent Fukushima Daiichi event hasn't been seen in its full scale yet, so it may end up being worse than 3 Mile Island. Let's take these isolated events in comparison with oil spills. Where there have been 3 large disasters for nuclear power, oil tankers have had quite a few more. So, here we can see a number of the largest disasters related to the production of fossil fuels and the using of fossil fuels. We have a few things like the Lakeview Gusher, as seen here, which resulted in 9 million BBL in 1910. The recent Deepwater Horizon, or better known as the BP oil spill, which was a total of 4,900,000. And the biggest one of all, which was the Gulf War, which was 11 million. But I suppose that wasn't really controllable. But that's a number of the largest ones, and in total, there have been 439 recorded oil spills. This is not to say that these nuclear disasters weren't catastrophic, but comparatively, they don't seem so bad. 3 events compared to a total of 439. It's not very comparable. Radiation. Radiation is a serious fear about nuclear power, that it leaks out of reactors and irradiates the surrounding area. In reality, 3 feet of concrete separate the reactor core from the outside world. The core itself also has its own reinforced housing. Add the highly trained technicians and overabundant emergency shutoff protocols, along with plenty of fail-safes, and it's almost impossible for any radiation to actually escape. These safety precautions are what prevented 3 Mile Island from leaking radiation to the outside world, because of the fact that its core actually melted 52% overall. Now, meltdown. Chernobyl is the only reactor to ever actually suffer a full meltdown. This was in part due to the lack of regulation by the USSR. The USSR had for its reactors. More specifically, no containment building. The incident also took place during a special test, not during normal functioning. Now, as for public opinion, instead of being seen as a normal part of life, nuclear power has become the subject of horror films, games, and music. The news also helps to reinforce this, with in-depth coverage anytime the word nuclear or radiation is even mentioned. The public has been trained to be scared of it, or think of it as an evil thing. If anything, nuclear power is the lesser of 2 evils. Even if nuclear power isn't perfect, it's at least better than the constant burning of fossil fuels. It only has possible hazards compared to spewing them out constantly like coal-fired power plants do. And there's plenty more room for the technology to grow. Not only renewable energy like in breeder reactors, but the idea of fusion, the same process that powers the sun. I hope you see that at this point, it's our only choice, and quite a good choice at that. So, nuclear power? Yes, please.